So for my project, I based it off the 11.1 notes, which have to do with known distribution and expected distributions, and determining the differences between the two. So here, with presidential candidates emerging and campaigns already at the beginning, the 2016 election is approaching quickly. In 2012, approximately 126 million voters showed up to the polls, and the numbers by race are shown in the graph below in millions. The expected voter turnout by race for 2016 was as follows: 70% white, 13% African American, 11% Hispanic, and 3% Asian. All the other missing values, since those don't total up to 100, are considered to be other and are not included. Assuming the same quantitative voter turnout with a 0.1 level of significance, how does the evidence suggest that voter turnout by race is different between the 2 years? So to get the data for this problem, I used bipartisanpolicy.org and citydata.com down here. Then the null hypothesis is that there is no difference in voter turnout between 2012 and 2016, and the alternative hypothesis is that there is a difference in the voter turnout between 2012 and 2016. Now, when I did this problem, I used both p-value and traditional methods, just because when you put the data into the calculator, it gave you both values, so it was pretty easy to just solve for both of them. To find the expected values, you use the percentages given in the equation and multiply them by 126 million. And then the work for that is shown down here, and then they are put in the graph as well in blue. Then once you take those two lists for 2012 and 2016, make list 1 in your calculator under the StatList app, make it list 1 2012 and list 2 2016. And then after that, you hit F6 at 7, and then make sure that it says list 1 and list 2, and then 3 in the boxes. Then that'll give you the degrees of freedom, or you calculate the degrees of freedom. Then it gives you the test value and the p-value. In this case, the p-value was insanely small, just because of the data that I had. So it essentially ended up being 0, just a very small p-value. Let's see, then shown in the graph, you can see the critical value 11.3 and then 31.7, which in reality would be much farther off the graph than where it is now. But by both examining the traditional method, the test value is within the critical range, so that would suggest that we would reject the null hypothesis, and also the p-value is less than 0.1, so that would also suggest that we reject the hypothesis. So, that being said, again, reject. There is evidence to prove that the voter turnout by race is different between 2012 and 2016.